Hello everyone, welcome to part 14 of my video series on probability distributions. So today we are going to talk about the negative binomial distribution, which is very closely related to geometric distribution and the binomial distribution. So without further ado, let's dive in. So let's assume that in my YouTube channel, a viewer subscribing is a successful event. That means if a viewer subscribes, it's a success and the probability of that is P. And if a viewer after viewing the video is not subscribing, it's a failure and the probability is going to be 1 minus P. Now, the probability of getting 4 subscribers from 20 viewers follows a binomial distribution because we have 20 events or 20 trials and we have 4 successes. So measuring that probability can be done using binomial distribution, and we have talked about this in part 6 of the video series. So there can be a few cases here. For example, one case can be viewer 2, 5, 8 and 11 have subscribed. That means we have 4 subscribers. Or maybe there can be another case where viewer 1, 6, 8 and 12 have subscribed. The other viewers did not subscribe. And there can be many such cases. Now, let's look at another scenario. What is the probability of getting my first subscription at the 20th view? This means the first 19 viewers did not subscribe. The first subscription happened only by the 20th viewer. So what is the probability of that? So this is something we discussed in the geometric distribution in part 13 of the video series. So now let's look at the negative binomial distribution. So that is something like this. Probability of getting the fourth subscription at the 20th view. Understand that this can be confused very easily with the binomial distribution. In the binomial distribution, we can get these 4 successful events from any place from the 20 events or 20 viewers. But here, the fourth success has to happen at the 20th view. So it's basically a combination of binomial and geometric distribution. So let's look at a few cases. Case 1 can be viewer 2, 5, 8 and 20 have subscribed. That means at the 20th event, we have obtained our fourth success. Case 2 can be viewer 3, 9, 17 and 20 have subscribed. Again, the same thing. We are getting our fourth success at the 20th event. So basically, the fourth subscriber will have to be the 20th viewer in this case. And the other 3 subscribers are from the previous 19 viewers. So this, I think, sounds familiar to you. So probability of getting these 3 subscribers or 3 successes from the 19 viewers or 19 trials, anywhere from the 19 trials basically, it will follow a binomial distribution. So we know the formula of that from part 6 of the video series. So we have to choose these 3 success from the 19 trials, and p cube is the success probabilities, and 1 minus p to the power 19 minus 3 is the failure probability. Now, the 20th event, so after the 19 trials, the 20th event or the 20th trial has to be a success according to the negative binomial distribution. So probability of that is nothing but p. So what is the actual probability of this whole thing? Probability of getting the fourth subscription at the 20th view. The probability of that is something like this. So you have the binomial thing and then multiplied by p. So it's very simple. So the 4 subscribers that we are talking about, you can denote it by r, and we have to get it at the 20th view. We can denote 20 by n. So the probability of getting rth success, that means the 4th subscriber, in nth trial, that means in 20th view, is going to be this formula over here, which is nothing but a generalized version of what I have written here. And we can simplify it because we can multiply p into p to the power r minus 1. So it will become p to the power r. And we can also subtract these things and get n minus r. So this is the probability mass function or PMF for the negative binomial distribution. So what are the possible values of n right here? So when we say n equal to 20, so what are the possible values of n? Now understand that n has to be at least r. So what does that mean? So if we want to get 4 subscribers, we have to at least have 4 viewers, right? Obviously, more than 4 viewers is okay, The fourth subscription can also happen at the 20th view, or maybe at the 100th view, or maybe at the 10,000th view if the channel is not working very well. So that is why n can be anything between r to infinity, and it's a discrete probability distribution because these values are all integers. Now let's look at the PMF function graphically. So let us fix this 5. That means we need 5 successes, and let us vary the probability of success from 0.1 to 0.9. You can see when we have 0.1 probability of success, the whole thing is extremely variable, right? Okay, let's understand the case for p equal to 0.1 first. So when p equal to 0.1, since the success probability is actually much lower, that means getting the 5 successes will take a lot of trials, right? That is why you can see that the peak here is somewhere at the 40th trial, right here, and it's very variable. That means when the success probability is low, you may need different number of events to actually get those number of successes, the 5 successes. When we increase the probability, you can see that the variance has reduced substantially. It is because now you are going to get those 5 successes in a relatively small number of events. Now, if we increase p further, you can see that in the very first few events, we are going to get the success, the 5 successes. So that is the significance here. Now, we can also vary r because r is also a variable here. That means the number of successes you want to achieve. It is also a parameter. So if we have r equal to 5, so understand that in all 3 of these plots, the probability of success is fixed. It is fixed to p equal to 0.5. When we require only 5 successes, we can achieve it using only a few events or few trials, you can also say. When we increase the number of successes required to 20, we need a higher number of trials in order to achieve those. That is why the peak of this curve shifted and there is also a higher variance. If we increase r even further, the number of required success even further, then the peak has shifted further and there is even higher variance. So that is how the PMF plot changes with the increasing r or the changing r. Now the expected value is extremely simple for this. We have derived the expected number of trials for getting the first success in the geometric distribution, and it was 1 over p. Now obviously we are not looking for the first success here. We are looking for the rth success. So it is going to be r divided by p. And as I showed before, as you have higher probability of success, that means you will require lower number of expected trials until success. That is why it is 1 by p. So when p increases, you will require lower number of trials. And what is the variance? So variance for the geometric distribution was this. So for negative binomial, it is nothing but you are simply going to multiply by r because now you require r successes. Finally, we have the cumulative distribution function. So there is no nice closed form right here. So we just have to sum over r to n, right? So basically what we are saying is probability to get the rth success on or before the nth trial. That means you can get these r successes in r trials or r plus 1 trials or r plus 2 trials or maybe in r plus n trials. That is why we are summing over r to n, and this is basically our PMF right here. So that is all about the negative binomial distribution. If you like the video, please feel free to subscribe and share. And we have a donation link in the description. You can donate to our channel to support our contents. Thank you very much.